2025 A-Level Combined Mathematics Paper 1 Part B, question number 15, Part B. Part A of this question was discussed in a previous video, link in the top right. Part C of this question will be discussed in a future video. Part A, B and C of question number 15 all have to do with integration. Part B says, show that the derivative of the natural logarithm of 1 plus sine 2x divided by cosine of x with respect to x is equal to 2 over cosine of x for x in the range 0 to pi by 4. Now this range is actually important because you might already see it. If you consider cosine of 2x, cosine of pi by 2 is equal to 0 and we're dividing by cosine of 2x. So if x was equal to pi by 4, then cosine of 2x would be equal to the cosine of 2 times pi by 4 cosine of pi by 2, which would be 0. So to avoid that, this range is going to be important. Now moving on, after that, it then says, using integration by parts, find the integral of the cosine of 2x times the natural logarithm of 1 plus sine 2x divided by cosine of 2x with respect to x. Now you can see this bit right here, the natural logarithm of 1 plus sine 2x over cosine 2x is exactly what we have up here. Meaning that there's some kind of relation and we're going to have to need to use the result obtained here in here. Now if you just take a look, using integration by parts, as we know, when you use integration by parts, you're going to have to at some point take the derivative of this and also take the derivative of this. So here, when taking the derivative of this, you can directly substitute the result that you have up here, since you already know the derivative of this expression with respect to x. So now, let's start off this question by first showing that the derivative of the natural logarithm of 1 plus sine 2x divided by cosine of x is equal to 2 over cos 2x for the range of x, which is in between 0 and pi by 4. So to start, if we consider derivative of the natural logarithm of 1 plus sine 2x divided by the cosine of 2x with respect to x, we know that if you have something like this where you have some internal expression inside of another function and taken with respect to x, if we consider this internal expression here as, let's say, u, this is going to be equal to the derivative of the natural logarithm of u with respect to x, which if you use the chain rule is going to become the derivative of the natural logarithm of u with respect to u times du by dx. Now this principle here is exactly what we're going to use in order to simplify this down. Of course, we're not going to write this u and all of that. We're directly going to substitute this as being the derivative of the natural logarithm of u with respect to u, where u is this internal bit, times du by dx. So if we go back and we do that, considering the derivative of the natural logarithm of u with respect to u, that's just going to be 1 over u. In this case, if u is equal to this bit, it is going to be 1 over 1 plus sine 2x over cosine of 2x, which if you invert it is going to be equal to cos 2x divided by 1 plus sine 2x. This needs to then be multiplied by du by dx, where u is equal to this thing right here. So therefore, we need to take the derivative of this expression on the inside of 1 plus sine 2x divided by cosine of 2x. Now since this function on the inside here is a ratio of two functions, this function is a ratio of 1 plus sine 2x and cos 2x, we're going to need to use the quotient rule when we find the derivative of this function with respect to x. Now since the quotient rule is a little bit big, I'm going to take this thing to the next line actually, and then we're going to write out the quotient rule. So the quotient rule says that if you have the derivative of one function f of x divided by another function g of x with respect to x, this is going to be equal to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Now if we apply this principle here, we can see the function of the denominator is going to be equal to cosine of 2x, so g of x is cosine of 2x, and the function of the numerator f of x is going to be 1 plus sine 2x. So therefore, if we apply this principle, we can see on the denominator, we're going to have cosine of 2x squared. So we're going to always have cosine 2x squared. Now as for the numerator, if we look at what we have on the numerator, we are going to have this thing's derivative, which is 1 plus sine 2x's derivative, which is going to be the derivative of 1 is going to be 0, and the derivative of sine 2x is going to be 2 times the cosine of 2x. So we have 2 cos 2x multiplied by the denominator, which is cos 2x over another cos 2x, and then minus, and then what we have is going to be the denominator's derivative times the numerator. The denominator's derivative of cosine of 2x is going to be minus 2 times sine of 2x, which is going to be minus 2 sine 2x, times the numerator, which is going to be 1 plus sine 2x. Now, if we simplify this down, we can see on the numerator we have cosine of 2x here, divided by 1 plus sine of 2x. And then here we have cosine of 2x times cosine of 2x times 2, which is going to be 2 cosine squared 2x. This bit here is going to be minus minus, which is going to turn into plus. So we have plus 2 times sine 2x times sine 2x, which is going to be 2 times sine squared 2x. And then we are going to have a plus 2 sine 2x times 1. So we're going to have plus 2 sine 2x. It's going to all be divided by the cosine squared of 2x. Now, here we can see we have 2 times the cosine squared of 2x and 2 times the sine squared of 2x. As we know, sine squared plus cosine squared of any angle, sine squared of any angle plus cosine squared of that same angle is equal to 1. Therefore, cosine squared plus sine squared would be equal to 1, but then we have 2 times cosine squared plus 2 times sine squared, so this whole component here is equal to 2. If we go to the next line and substitute, we can see if we cancel out one of the cosine 2x's for this cosine of 2x, we're going to get 1 over 1 plus sine 2x times, and on top we're going to have a 2 plus 2 times the sine of 2x divided by a cosine of 2x. Now, at this point, since we cancelled out a cosine of 2x for a cosine of 2x, we need to mention that the cosine of 2x is not equal to 0, because then in that case we would have a 0 divided by 0. So at this point, I'm also going to mention that cosine of 2x not equals 0, as we know that the angle x is in between 0 and pi by 4. So since x is not equal to pi by 4, 2x is not equal to pi by 2, and 2x not being equal to pi by 2 implies that if we take the cosine of that value, then the cosine of the value is not going to be equal to 0. So the cosine of 2x here is not equal to 0. So at this point we did not have 0 divided by 0. Now, moving on, here we can see we have a 2 and we have a 2 times the sine of 2x. If we factor out that 2, we can see we have a 2 times 1 plus a sine of 2x. So we can see on the denominator here also we have a 1 plus the sine of 2x. If we cancel this for this, what will be left over with is a 2 on the numerator, meaning that if we cancel the 2 out, we're going to be left with a 2 divided by the cosine of 2x. And that is going to be our answer, and that is also the answer that we're expected to provide in the question. So then we've completed the first part of this question. Now, considering the second part of the question, the second part says, using integration by parts, find the integral of cosine of 2x times the natural logarithm of 1 plus sine 2x divided by cosine 2x with respect to x. Now, in order to solve this using integration by parts, we're going to be needing this result that we have up here. So, in order to identify how we can use this result, let's consider what integration by parts is. Integration by parts says that if you have the integral of u times v prime, where u is some function and v prime is the derivative of some function v, then the integral of u times v prime is going to be equal to u times v minus the integral of u prime times v, where v is the integral of v prime, or v is the original function whose derivative is v prime, and u prime is the derivative of the function u. Now here we can see this is actually coming from the fact that if you take the derivative of uv, it's going to become u times v prime plus v times u prime. So anyway, we can see that this is what we're going to be using in integration by parts. Now, if we know what u is and we know what v prime is, we're going to need to find u prime and we're going to need to find v. Therefore, if we know u prime and u and v prime, we're going to need to take the derivative of u but take the integral of v prime. Now in the case of what we have up here, we have two functions multiplied together and an integral sign around them. We have cosine of 2x and the natural log of 1 plus sine 2x divided by cos 2x. Now, both of these we know how to take the derivative of. We know how to take the derivative of cosine of 2x, and as we found prior, we know how to take the derivative of the natural logarithm of 1 plus sine 2x divided by cosine of 2x. However, in terms of which of these we can take the integral of, the only one of these two functions that we know how to easily take the integral of is cosine of 2x. We have not yet tried to figure out how to take the integral of this thing, and it's probably going to be complicated. For that reason, we would like if we could integrate this function and take the derivative of this function. Now, in integration by parts, the function that we need to take the integral of is going to be v prime, which means if we make this v prime, we can easily find it, and the function we take the derivative of is u, so we could make this u. Now this is what we're going to do. We're not going to do it the other way where we take this as being equal to u and this is being equal to v prime, because if we do so, we're going to have to take the integral of this thing right here, which is something that we cannot easily do right now, and we'd much rather take the derivative of it since we already know it. So, applying this down here, if we say let we take the derivative 1 and as in the u as being the natural logarithm of 1 plus sine 2x divided by cos 2x, and we're going to take v prime as being equal to the cosine of 2x, which is the other function. In this case, if we take u prime and we consider v, u prime is going to be the derivative of this expression that we have up here, which we already found to be equal to 2 over cosine of 2x. We could potentially also say over here from above, since we did in fact find the derivative of the natural logarithm of 1 plus sine 2x divided by cosine of 2x above. Now, as for the other part, we have v prime being equal to cosine of 2x. If we take the integral of this thing here, we can see if we do u substitution, 2x would be equal to u, and we'd have the integral of u, which if we do all of the maths is going to be equal to 1/2 times the sine of 2x. Now, given all of this, if we substitute this into a final expression of the integral of u times v prime being equal to uv minus the integral of u prime v, then considering what we have, the integral on the thing of the left, which is what we had previously, which was the cosine of 2x times the natural logarithm of 1 plus sine of 2x divided by cosine of 2x with respect to x, which is what we had previously, where we substitute this for u and this for v prime, is going to be equal to uv, which as we found down here is equal to half sine 2x times the natural logarithm of 1 plus sine 2x over cos 2x. So I'm going to write half sine 2x times the natural logarithm of 1 plus sine 2x divided by cos 2x, and then minus the second part, which is the integral of v prime times u, actually u prime times v. U prime here is equal to 2 over cos 2x and v is equal to 1/2 times sine 2x. So multiplying the two together, that bit is going to be equal to 1/2 times 2. Actually, we'll write the whole thing. I was going to write only part of it, but we'll write the whole thing. 1/2 times the sine of 2x times 2 over cos 2x dx. Now simplifying down, this left side has nothing to simplify, so we can write that directly as half times the sine of 2x times the natural logarithm of 1 plus sine 2x divided by cos 2x, and the other part, the minus bit, is going to be the half will cancel with the 2, leaving us with just 1, and then we have sine 2x divided by cos 2x, which is equal to tan 2x. So therefore we get tan 2x's integral with respect to x. Now finally, for this integral right here, I'm actually going to take the minus 1 into the integral, as in this minus here, I'm going to take it into the integral and write this as being equal to half times the sine of 2x times the natural logarithm of 1 plus sine 2x divided by cos 2x plus the integral, and instead of having tan 2x, I'm going to write minus sine 2x divided by cos 2x dx. Now consider here, we have one function divided by another function. But if you take a look at the function cosine of 2x and you consider the derivative of cosine of 2x, the derivative of the cosine of 2x is going to be 2 times negative sine of 2x. Now from that we can see on top we have just negative sine of 2x. So in order for the top to be equal to derivative of the bottom, we need just a factor of 2. So I can actually do that by taking a half outside and adding a factor of 2 in here. So if I do that, we can see we have now negative 2 sine 2x on top, and we have cos 2x on the bottom. Now this is of the form of the integral of the derivative of a function divided by the original function with respect to x. And as we know, this is going to be just the logarithm of that function, the natural logarithm of that function. So now we can see we have a half times the natural logarithm of the function, which in this case is cosine of 2x, which will give us a final answer of 1/2 times sine 2x times the natural logarithm of 1 plus sine 2x divided by cos 2x, and the rest is going to be a half times the natural logarithm of the denominator function here, which is going to be the natural logarithm of the absolute value of cosine of 2x, and of course at the very end we cannot forget the constant of integration plus c, since this right here is not a definite integral. So we have to say additionally where c is an arbitrary constant. And that is going to be the end of the answers for this particular question. Now finally, if we consider the marks awarded at the start, when you take the derivative of the natural logarithm of 1 plus sine 2x divided by cos 2x, and you use the chain rule where you take the derivative with respect to the internal bit and write this part right here and multiply it by du by dx, where u is equal to the internal part, which is all of this, you get a 10 marks for all of that. So if you potentially done this in multiple steps, maybe sometimes you would have wrote this as first the derivative of 1 plus sine 2x divided by cos 2x with respect to x, and then solve it. Then you will get the 10 marks distributed among that. But in the mark scheme, they've only given 10 marks for the whole thing. So after that, when you get this result, you simplify down. At this point where you divide out a cos 2x from the numerator and denominator, when you cancel that out by the fact that you have to write that the cosine of 2x is not equal to 0, otherwise you get 0 divided by 0, and then you get to this point right here, you get 5 marks. After that, when you simplify the rest of it down, get rid of all of the extra terms, as in this 1 plus sine 2x and this 1 plus sine 2x here, and get to the final answer of 2 over cos 2x, you get another 5 marks. Now, in the second part of the question where you have integration by parts, for the start bit they have not given in marks here, but this is of course all necessary. You really should write all of this, but then they've only given marks for when you actually apply that knowledge and say that the integral of cos 2x times the natural logarithm of 1 plus sine 2x divided by cos x, the cos 2x dx, all of this is equal to, and then you apply integration by parts to get all of this, you get 10 marks. After that point, when you go down and simplify, clean it up and write your final answer as this right here, you get a 10 marks complete for all of this. So it's probably this bit and this extra line. These are all written in one line, so I can't really tell where exactly the marks are coming from. But writing all of the final answer correctly, including the plus c, and writing that plus c is an arbitrary constant, you get a full 10 marks. So that is the end of this question. I hope you enjoyed. If you have any feedback, post in the comments down below. Thank you for watching and goodbye.